damaged drives, it won't come up if you can't get it to actually initialize. What is your problem? And they are not going to help you out. So skip most of those things. They're not going to do a lot for you. Same thing here. You always want to save the state of your drive. You do not want to be messing with the drive in instances where a check disk, fixed disk, or anything else is going to make changes to your disk. I also removed SpinWrite from my list from a standpoint of don't use it because it makes changes to your original drive. It does not write to a destination disk. It may do the proper thing. Unfortunately, it doesn't write it to another disk. So if that disk dies or there's further damage to the disk, it's the last time you ever saw it. So unless they are going to change this to write to a destination disk, I just don't approve calling it data recovery software because data recovery software should recover to someplace else, not to the drive that you're actually, your original drive and what it is. So those you just basically need to say no. Frozen drives. Now, you know, a lot of people go, oh, this is a myth, whatever. It really isn't a myth. It does work. Unfortunately, it's not the best thing to do to a drive. If you freeze a drive, basically the idea is there's something that might, you know, maybe the board or something like that is damaged or the contacts have, you know, moved away from each other from heat or something. And when you actually are freezing the drive, it causes everything to contract. And then maybe you actually have a contact or something that will survive for a little while till it warms up again and it dies. But at the same time, you may get even condensation or temperature changes that may do damage to it. So if you're lucky enough to get it to work and you're going to do that on your own, you got like 10 minutes maybe before the drive might die again and you're done. So if you're going to try that as a last resort, great, but it is not a great diagnostics process to just like throw it in the freezer and hope that it's going to work when you're done. But if you got nothing else, you know, I just don't approve of it. USB. This is another thing I hear all the time. Is everybody goes, well, you know, I plug this into my USB adapter, I'm trying to recover data, blah, blah, blah. You guys might have forgot, but USB sucks. USB sucks. When you plug this drive into USB, the ATA command set is not really in its full capacity and running and doing what it can do. It starts up a driver. In any operating system, it basically starts up a driver to talk to the serial port, and it's a mass storage driver. It's a generic driver. It has no real fundamental control, so you can't do error recovery and you can't do ATA commands that are going to give you any good response. So there's not a lot you can do there. Trust me when I tell you, drives you might have now you've tried to recover from by plugging into a USB adapter, if you go find a motherboard and you slap it on the table for 40 bucks and you put a power supply on it and try to recover from it connected to an ATA command set, to a controller, to SATA or an IDE, or you know, go buy a RAID controller and plug it in, you'll be able to read those better than you ever were through a USB adapter. So don't be going, oh, my laptop's all I have. Well, whatever. I'm just saying that that's not the best way to go. You could use eSATA if you needed to, but USB sucks. And these things, I mean, they're cheap-ass Chinese boards. Whoever's got, you know, whatever the cheapest chip is today, and it's very, very simple stuff when they put it in these USB adapters or these USB external kits and stuff. You're paying like $13 or whatever for them. They're terrible. So skip those. Go get, you know, you can even go on eBay and buy like an old Adaptec controller, like a 1200A, that's like 12 bucks on eBay. And it will do a much better job at data recovery and error control than the crap that you're trying to use on USB. So basically, I want you to know you need to do anything that you're going to do for diagnostics with an ATA controller. There are some free tools out there that actually do some rudimentary, low-level diagnostics, like MHDD and Victoria. So again, I don't expect you to remember these things. Go hit the slides off my website, and those are the links to them, so you can go get them. You can switch from UDMA mode to PIO mode. You may actually get more. I actually did another talk on that, so you can go look at videos or whatever. And then you want to try reverse imaging in this process of actually trying to do something. So one of these tools for reverse imaging may work, and if you have money, spend it on a deep hard disk imager or another cloning machine or something. But in the process of trying to educate you, I want to talk about SMART as part of your diagnostics process, because a lot of people go, you know, isn't SMART supposed to tell me that this drive is, you know, bad or blah, blah, blah? Well, SMART sucks. You guys know this? SMART sucks. So I'm going to explain to you why SMART sucks. One thing, though, I want you to understand where SMART data comes from. It's very, very important to understand where the SMART data is written to from a diagnostics perspective and what it's doing, because it can be useful to you for diagnostics. It is useless to you in using your drive, but it may tell you a lot about the state of the drive, not because the feedback you get from SMART tells you anything, but the fact you could read SMART at all tells you something. So here's the story. So your hard drive has basically a little mini operating system on it. It's as complicated as anything that you know, even in a normal operating system or any other, car or whatever. It has similar post routines to what your machine has. But it goes through this initialization phase where it does self-checks, it does the spindle spin up, make sure that the heads unmount, and then it goes into reading what's called the SA area. So this red line I've got on the outside, it can be in a couple of places on the drive. Usually it's in the center, the outside edge, or it could be in the middle. So somewhere on the platter, you will normally have the system area. And so that SA area is very, very important because that's what we're trying to find out if the drive got through any portion of that so that we can say in our mind, well, I know where it was and what has happened. So let's talk about that for a second and what's in the system area. So the system area has smart data in it. So there's this extra little area that before you ever get to your user data, that these smart logs and this other content from the system area has to load. So it does not matter if you can't read your user data. If you can't read the smart data, in most cases, you're not going to get to your user data. Something else has happened, an exception has happened, or it has failed. So we have smart data. We have things like system logs, your serial number, and your model number. Now, this has changed since like 2002. Prior to 2002, you may actually get a model number or a serial number. You'll usually lose like a size, like it won't give you the geometry of the disk, or it'll say something stupid like 2 terabyte for a 40 gig drive or something. So it's important to follow whether or not your serial number and your model numbers have been interpreted correctly, even at a lower level when you're talking to a tool like MHDD. Because you can use MHDD to look at this damaged drive, and you can tell it, you can say Shift F2, and it will tell you what's my model number, my serial number, my drive, even if your BIOS never showed it. It's still possible to see it. So it's important, though, to know that the smart data is coming from that. So is things like your bad block list, your serial numbers, and your model numbers. So this is why Smart sucks. Smart thinks, it's supposed to be about predicting whether or not your drive is going to fail. But these numbers are just these arbitrary numbers that somebody made up and stuck into these for threshold numbers. And a lot of people don't even know what they mean or understand what they are. And when your drive is starting up and your BIOS sees it, the whole point is to boot very fast, to boot as fast as possible. So a lot of the extended checks are all turned off, so that you have a 5-second boot time or a 7-second boot time or whatever it is to make Windows boot faster or Linux boot faster or whatever. So it does a very generic check. It's not doing very comprehensive work at all. So, and in some cases, it's completely disabled. Like it doesn't even do a check at all. It doesn't even bother to tell you that this isn't working. The other thing is too, smart tables can actually cause the drive to fail. In other words, you don't need smart. It actually provides you nothing that you need to make the drive work, but it can stop your drive from working. The reason I say this is that the way that the drive works is it goes through, it loads the system area, it loads the content from these tables, and if the tables are corrupt, there's very, very little error checking that it does to say, hey, look, I didn't mean for this buffer overflow or something else to happen. It causes an exception failure, and the drive's code actually sees an exception and just farts all over itself. It doesn't do anything else at all. It just stops and basically freezes in time with a firmware failure because of the smart table. So data recovery people, the first thing they do when they hook it up to a piece of equipment is clear the smart table because we don't need it. It's worthless to us. It tells us nothing except that either I read it or I didn't read it, nothing else. So, and this is what it looks like. It looks like, just a bunch of arbitrary numbers. This is a tool called GSmart Control. Some of you may have seen it before. You can go and find out what some of the things are that mean something. But again, warranty applies in a lot of cases. If your drive says I'm failing, you'll send it back to the manufacturer and say, your drive said it was failing, please replace me. Well, they don't want you sending it back. It's under warranty. It's going to cost them money. So there's a lot of numbers that have been changed maybe to make these thresholds higher than they should be, so that if it fails, that the manufacturer isn't paying for it. That's ultimately the point. How many people have seen that message that comes up on your screen that says, your drive is failing, imminent failure, please replace my drive, right? How many people have had a drive? So like 5 of you. How many people have had a drive fail? Wow. That tells you a lot right there. But when smart works, normally that means something really good to you. Think about this. You have a head. Is the head good? If the head read data from any place on the drive, you have at least one head that was good for the system area. You may have multiple heads, and maybe a head is bad. But one head for the system area had to go and read data from the system area to read the smart table to report it to you, which means I've at least got one good head, right? Everybody good with this so far? There's a few exceptions, but ultimately that's what we're talking about is we got a system area and a head read data, which means I probably have a good head, which means I might be able to read other data, even if I have another bad head that might not be able to read some data. And I'll explain all that stuff to you in a minute. But ultimately, my whole point is now I know to stop, because also what happened, if the head read data from SMART and returned it to me, what else must probably be good? What? The controller, the board, the controller, and your firmware is probably at least running, right? You've probably at least made it through that part. So you already know right away if I'm able to read some SMART data, I may have made it further than, it doesn't matter if I'm reading user data, I may have actually been able to tell that the drive initialized correctly and it made it through this post routine because it will be one of the later things that actually happens. There are a few exceptions. Almost all of these exceptions have basically happened in the last year, year and a half. So I'm going to talk about these really quick before we go to the diagnostics component. First one is, everybody heard of Seagate 7211's firmware problem? Right? So there's at least 2, maybe 3 firmware problems that exist on these Seagate drives. We can fix at least 2 of them now. And when I say fix, we can't always make them work exactly the same way they were supposed to work, but we can make them work well enough to read the data from them, and then you throw the drive away, right? You guys good with that so far? Because the data is important, the drive is cheap, or should be. So basically, there's a firmware bug, and it can be fixed. And a lot of you probably know. Anybody ever had to send a drive to a data recovery company to fix this firmware problem? No, besides you. No, nobody knows, because you probably just don't even know. You probably just had, oh, a Seagate drive died, I mailed it off. And so they could charge you thousands of dollars to fix this firmware problem that there is a patch for. You can fix it for $25, okay? You can fix this problem for $25. Here's what you do. There's a cable. I even gave you the link to the cable. Go to the website, download my slides, click on the link, go to the cable. $25. There's your $25. Then you can go, and you basically have to get the firmware downloads. I have a web page that also has the firmware stuff up for the Seagate stuff. You are going to take this cable, and you're going to cut it, and you're going to connect it to a serial port. Now, on the back of all Seagate drives have a serial port that works just like a modem. You hook up these 2 wires, you start up terminal, and you talk to the drive through a serial port. It does not even need to be, and I don't mean the SATA interface, I mean there is a serial port. I mean a courier modem blinks at you, you unplug the cable, you plug it into, that's what I mean, literally. So I'll show you that in a second. But ultimately, these pins over here that most people didn't even know that would normally set your speed, which are usually set, by the way, to a default of limit my transfer rate to 1.5 gigabit. Not that you have a controller that can do this anyway, so it doesn't really matter, or a drive that spins that does this, unless you have solid state. But most of you didn't even know you probably had a jumper there that set that to 3 gigabit versus 1.5 gigabit. Anyway, that's what that jumper is. You hook up these 2 wires, the orange wire from that list and the yellow wire, and you plug this into a terminal. And you will be able to tell almost all diagnostics problems with Seagates. Whether you understand them or not is a different world. But you can see on a terminal screen what is wrong. The Seagate drive will actually tell you, I'm a Seagate drive, here's my firmware, here's my model number, here's my stuff, and it'll tell you that right there. And then if there's a repeating error, it will tell you what the error is. And there also is like a static. Now, when I tell you that there is a terminal and you can hook up a wire to it and you can see what's inside your Seagate drive, this is not a typewriter, okay? Do not just start, woo, I can write Word documents in this, okay? Because your drive will do things based on individual characters so don't just be like hitting random keys. I can tell you hit something like a period and it will give you a status line that it will actually talk to the drive, it'll say what is your status, and it'll give you back a health line and it'll tell you everything it needs to know in one health line. Now you still have to interpret what that means. So, but all Seagate drives of all IDE, SATA, or 3.5, 2.5, they all have a serial port. This is going to be a small video on what this particular bug called the pending bug is. This is not one that you can fix, okay? If you see a screen that looks like this, when you physically hook up a cable and you're looking at your diagnostics, it's cool just to see it if you're just even doing diagnostics, but you cannot fix this problem. So if you see this, you know right away this is not something you can do. It will just keep looping through this process. Now what this type of bug is about 20 seconds after a Seagate drive is initialized, it will start going through doing checks to see what bad sectors are and doing wear leveling, shuffling bytes around on your disk. Yeah?
Just off topic, but can that serial cable read and write data to the disk?
You can really send commands to the system area or to a command processor, and you could like format reinitialize disk and stuff, but that's not its purpose. So you have to know quite a bit of commands. There's like 75 pages of commands. So there's a lot of things that you can control, but it's primarily for firmware. And I mean, you know, one other question that came up is, well, maybe I could actually write a little piece of malware and stick it in there so that we might drive. So there may be some plausibility to doing that, but